Hello, I'm Sarah Jane Sanchez and I'm here to share with you the Diwata2Tracker. Later, I'm going to demonstrate the tracker and share some of the libraries that we use to create this program. A little info about myself. I'm a university researcher at Stamina for Space Program or Space Technology and Applications Mastery Innovation and Advancement Program. So this program is a space research and development program which aims to further develop deep expertise in space technology and applications in the Philippines. So to know more about Stamina for Space, you may visit the website staminaforspace.upd.edu.ph. So what I do as a university researcher, I specifically work as a front-end developer, and one of our projects this year is to create the Diwata2Tracker. So what is Diwata2? Diwata2 is a 50-kilogram Earth observation microsatellite of the Philippines built by researchers of UP Diliman and DOST-ASTI in cooperation with Tohoku University, Hokkaido University in Japan under the Field Microsat program. So it has the Enhanced Resolution Camera or ERC for pan-sharpening images captured by the SMI and Experimental Amateur Radio Unit or ARU, which can be used as an alternative mode of communication for emergency response. The tracker that we made is a real-time tracker that shows the coordinates of Diwata2 in space. This is useful for amateur radio users who have been accessing Diwata2's amateur radio unit or anyone who just wants to know where our microsatellite is currently hovering over. Let us now visit the tracker at tracker.staminaforspace.upd.edu.ph. This is the Diwata2Tracker. The first thing that we will see is the 3D model of Diwata2. There. Then, this yellow line represents the path or track of Diwata2. On the upper right is the description box of Diwata2 where you can see the time, longitude, latitude, and elevation. On the lower left, you can see the time-lapse control. You can stop and return it back to its default mode by clicking this button. Then, let's click this home button so we can view the whole Earth. You can also search for an address or landmark using this search bar. You can also change the map view from 3D to 2D mode. You can also change the style of the map. Then here is the navigation instructions. These small images are the ground receiving stations where it can download images captured by Diwata2 or upload commands. Then you can click this button on the upper left so you can go back to its initial view where it zooms into Diwata2. Now let's discuss the libraries that we use to create this web app. The first library that we use is React.js. It is an open-source front-end JavaScript library for building user interfaces. It can be used as a base in development of single-page or mobile applications. The next library we use is Resume.js. It is an open-source JavaScript library for creating world-class 3D globes and maps with the best possible performance, precision, visual quality, and ease of use. Basically, it is the whole look and feel of this web app. From this toolbar, description box, the interactions, and the time-lapse control are all features of Resume.js. What I like about Resume.js is it is easy to customize and it has a library of React components called Resume. You may learn more about Resume at resume.darwineducation.com. Lastly, Satellite.js. Satellite.js is the library that we use to calculate the path or the track of Diwata2. So it is a library to make satellite propagation via TLE or two-line element set possible in the web. Provides the functions necessary for SDP4 calculations as callable JavaScript. It also provides functions for coordinate transform. So to learn more about Satellite.js, you may visit this GitHub repository. As a recap, we use React.js for the base of this web application. Then we use Session.js for the whole look and feel, from the interactions, time-lapse control, description box, toolbar, are all features of Session.js. And this yellow line, we calculated this using Satellite.js. That's all. Thank you for listening.